Good afternoon, everyone. My name is Furkan, and this is my friend Umut. We are here today to present our review on performance optimization in virtual file systems. Today, we are going to look at why modern file systems slow down in cloud and the specific techniques we can use to speed them up. Let's begin with our core concept, the virtual file systems, or VFS. Think of VFS as a universal translator. It allows Linux to talk many different storage formats without the user noticing. However, this translation layer isn't free. As you can see here, it introduced significant overhead, specifically in how it handles metadata and resolving file paths. In high-performance environments, this convenience becomes a major bottleneck. You notice these hold file permissions and ownership. The entries these maps are file names to those in nodes. The page cache is the memory used to speed up access. The bottleneck happens because constantly looking up nodes and entries consumes CPU cycles. And if the page cache isn't managed well, the system stays still waiting for the disk. This problem gets much worse in cloud computing. We call this virtualization bottleneck. In a virtualized environment, you have the multiple virtual machines fighting for the same physical disk. Not only do you have the standard VFS overhead, but you also have the hyper-supervisor layer adding extra steps to every single file lookup. It creates a chaotic environment for in-out contention. Before we get the solutions, we must acknowledge what sits beneath VFS. We have the standard systems like XDD for which is reliable and modern one like BTRFS and VFS that use advanced trees and caching. Our goal isn't to replace those, but to optimize the VFS layer above them so it doesn't throw their performance. Now I will hand over to Umut to discuss the specific optimization.
Thanks, Furkan. So how do you fix this? This first target is path lookup. Usually to open a deep file path, the system has to check every single folder in the chain. This is inefficient. The solution is stage lookup or directory shortcuts. By creating a cached shortcut directly to frequently accessed deep directories, we can skip the intermediate steps entirely. This drastically lowers latency for web servers and complex applications. Our second target is storage hierarchy. RAM is fast but expensive. Disks are slow but cheap. We propose a multi-level caching architecture. We keep the hot data, the stuff used right now, in the RAM, DRAM. But instead of going straight to the slow hard disk for everything, we use an SSD as a middle ground warm cache. This balances speed and cost perfectly. Finally, we address the noisy neighbor problem in virtual machines. In a standard setup, one heavy user can flush the cache for everyone else. We use partitioned caching like vcache share. This gives every virtual machine its own dedicated slice of the cache. Even if one virtual machine goes crazy with data, your virtual machine remains protected and fast. So what is the impact of these changes? If you look at this chart, the red bar is the standard system. Just adding shortcuts saves us about 30% latency. Adding multi-level caching gets us 55%. But the green bar shows the fully optimized system combining shortcuts, caching, and partitioning reduces latency by 70%. That is a massive gain for any data center. To wrap up, VFS optimization is essential for the future of cloud computing. We have shown that by fixing path resolution, implementing tiered caching, and making the system aware of virtual machines, we can solve the major bottlenecks limiting modern servers. Thank you for your listening.